Dennis,
Yeah.
where's your Cardinal Ritter?
Under, I got it.
Okay, let's take care of that.
Are you gonna record us? Our class?
But it's not really about you.
You don't know how to.
Okay, it's for her.
Put it in our bag. Nope, no, no. Okay.
We made it.
Welcome to town.
I checked in your class, but you are there.
And here we are, folks. Time to get going. Happy Friday to you. Bell work is on the board. It requires no instruction from me, other than what I have placed on the board. I will take a look, but let me work on attendance first. Folks, I need you in your assigned seats at this time, so I don't miss you during attendance. Hayden, Adolfo, please. And at this time, I am looking to collect your homework. Please have homework out on your desks for me to collect. That is your section 5-6 problems from the textbook. Hold on, give me a second, I see the hand, I'm getting an attendance. Looks like we are all here, all over it.
That's a 7 to 17 on.
Just 1 second. That is correct, that, you are looking at the right section. Yes, ma'am. Your keys here? Let's see, this your assigned keys? Let me check the chart.
Bruh.
Folks, please continue working. Folks, please continue working quietly and individually while we get settled in for the day. This is your warm-up. Hold it, complete it, hold on to it. We'll come together shortly. Daniel, could you please move 1 seat back for me? And Miss Peyton, come out front. Forgot, didn't have the seating chart memorized. How are we doing on the warm-up? Okay, I'm gonna make my way around to collect homework at this time. We'll come together shortly. I didn't have a chance to check yet if I have next, but I'll take a look for you. Homework. Come on, Jennifer. Homework, Peyton. Dennis. Homework. We're gonna come together and we're gonna review all these answers real shortly, okay? together to review those answers. And like our slide up front mentions, if you're done with that warm-up, go ahead and get your study guide packet out. If you're waiting for us to come together, you can spend a little time there and we'll be working through it together as well. Did I see a hand up over here?
Yeah, when we got to our package.
On test day, Tuesday. I've got more announcements coming.
So he's gonna work on the study guide, right?
We're gonna work through some of the problems on the study guide together. I got a plan of action for you, and I've got some announcements when we come together in just a
Will
second.
we be able to work on the study guide after that?
Hang tight, more information is coming. Good questions. Okay. Hopefully we've had enough time to get this little bell worksheet out of the way. I'm not grading it for accuracy, so no risk in getting a wrong answer, but let's go over the answers that you got together here. Question 1, which one of these is not a way of writing linear equations? What'd you put, A, B, C, or D?
C.
C, okay, any other answers? Yeah, Jennifer. Okay. Jennifer got D, did anyone else get D? D, none of these? Oh. Why don't you ask a question? Ask someone around her. Indeed, the D's have it. Correct answer to number 1 is D, none of these. Question 2, which of these is not a way, or I'm sorry. Okay, I apologize, I couldn't multitask. Question number 2, the two lines are parallel if their slopes are A, B, C, or D. Jennifer, you steered us in the right direction on the first question. Let's see who else has it. Dennis. First answer to question number 1 is D.
Yeah, we're on number 2.
We are on number 2. Vishon.
B.
Well done, Vishon. Two lines are parallel if their slopes are B equal. Question 3. Two lines are perpendicular if their slopes are A, B, C, or D. Narubi. C. Absolutely well done. Two lines are perpendicular if their slopes are C. Negative reciprocals of each other. Review from last class. Number 4. The slope of the line perpendicular to the line y is equal to 3x plus 6 is? Jennifer. Yes, well done. Right there, negative 1/3 is the negative reciprocal of 3. Okay, problem 5. I am actually gonna put a pin in this one and we'll come back to it. Problem 5 is tying together a few things from throughout the unit, including slope-intercept, point slope, and parallel and perpendicular lines. And our task of the day is to review all the things from this unit. So we're gonna kind of circle back on problem 5. At this time, please come on up and walk your bell work into the frame.
Daniel, why you do that? Hey, that is that. That was you.
Okay, before we get into announcements, let's come together in prayer here. If you could please join me in standing and facing this face. Does anyone have any intentions that they would like to share at this time? Okay. In the name of the Father, and the Son, and the Holy Spirit. Christ the teacher, we ask that you bless all those who guide us at school. May they lead us through your example as a teacher. May they inspire us to follow your way and help us to grow in body, mind, and spirit. And may they always trust in the impact they have on the many lives entrusted to their care. We make this prayer in your holy name. Amen. In the name of the Father, and the Son, and the Holy Spirit, please be seated. Okay. A reminder of where we are and where we are going. Today we are reviewing for our Unit 4 test. Time is a valuable resource for us today, as we have a lot to fit in to one day. Tuesday we will test, and I will collect your study guides. Thursday we will review for the final exam. Our agenda today, we've got a class in 2 parts. Lots to get through. Again, time's kind of the enemy today, but we're going to use it to the best of our ability. So stay with me. I have class in 2 parts. Before we head to lunch today, I'm going to guide you through some practice. So I have problems up on the board that we will review, as well as we will work through problems from the packet together. When we come back from lunch, we are going to do a group activity. What I have planned for you is to play a game of Jeopardy! Now, as always, group activities, while very fun, do require our collaboration. So that's plan A, and I would love to proceed with that as long as we can kind of stay focused and make it a productive time. If not, we might need to pivot to maybe some more kind of settling things down by working on our study guides, but I certainly hope to stick to plan A. Okay, in review, a reminder of where we have been. This is Unit 4 on linear functions, and it is Chapter 5 from the book. So, I know, for example, I think the packet, the study guide in front of you says like Unit 5 study guide. For us, it is the 4th unit we have covered, but it is Chapter 5 from the book. At this time, please have out something to write with, your study guide, and I would suggest your notebook or scratch paper as well. Is anyone in need of another copy or a new copy of the study guide? Please raise a hand at this time if you need a new copy of the study guide. Got it. Okay, I got you guys. So a reminder of where we have been is on the board in front of us. We have spent at least a half a day, or in many cases, a full day of class on each topic on the board. We started with verifying whether x, y, an ordered pair satisfied a linear equation. Then we began plotting points on the coordinate plane using those x, y directions to find our way on the x, y axis of the coordinate plane. We found slope 2 ways, from a graph and from a table and 2 points. Then we looked at equations of vertical and horizontal lines, slope-intercept form, point-slope form, standard form, and the last time we met on Wednesday, we covered parallel and perpendicular lines. So kind of looking from oldest to most recent information here on the board. Lots to fit into one day. We're not going to get into everything, but I'm going to try to do my best to prepare you and get you in good shape for the test so you know what to prepare. What to expect come test day, your test contains 4 vocab questions with a word bank, 3 matching formula to form questions. So for example, given the term slope-intercept form, draw a line matching it up to the right equation. A lot of these questions that you're going to see on the test look really similar to what's on your packet. I'll highlight some of those things to expect as well. You're going to have 12 multiple choice questions worth 2 points apiece, 4 options, A, B, C, or D. You have 2 instances where you will be given a graph and asked to find the slope from it. And then 4 problems where you will be given a graph and asked to plot the line or the equation on it. 3 examples of writing equations problems, either using point slope, slope-intercept, or standard form. 2 questions where you will model or interpret data. And lastly, 4 questions regarding parallel and perpendicular lines for a total of 82 points. Okay. First up, I want to keep these really handy for our reference today, our 4 formulas. Could I get a brave volunteer to write each of these up on the board? You're welcome to bring your packet or notes along with you. Could I get someone to write our formula for slope on the board? I would hate to voluntold. Okay, wonderful, Jennifer. Thank you so much. Let's start at top left. Slope. M is equal to, oh, do you know it?
Is it the y equals mx
Oh, nope, that's slope-intercept. Why don't you go jot that one down? That one's top of mind. You can jot that down. Oh, we're right here though. Slope-intercept form, right here.
The y minus y minus.
Okay, sure. I just thought we were getting ahead of ourselves for a second. Is equal to, and we use our variable m. Well done, Jennifer. Thanks for keeping that handy for us. All right. Another volunteer for slope-intercept form. Thank you, Vashon. Come on up. Perfection. Y equals mx plus b. Point slope form. This one's a little longer. I'll even volunteer to write it if someone volunteers to read it out for me. It's on page 1 of your packet. Starts with a y. Yeah, Anthony.
Y minus y1, which is m, parentheses x, minus x1.
Absolutely. Ooh, messed up. Absolutely. Point slope form. Y minus y1 is equal to m x times x minus x1. And lastly, can someone please jot down our standard form up on the board for me? Sanji? Peyton? Jot down standard form for me? Yeah, you know it. Come on up. Okay, we are going to reference these 4 formulas or equations many times throughout the day. So not only do we want to keep them handy here on the board, but we want to commit these to memory come test time. Thank you to all of my volunteers for your participation. Let's come here and let's come together to review what we know about slope. Slope is represented with which variable? Yeah, you betcha. What are other ways that we refer to slope? Yeah,
Rate of change.
excellent. It's like you read my mind. Rate of change, as well as, I can think of at least one more. I just heard from you. Let's hear from someone else. Someone else. I just heard from you as well. Let's keep the juices flowing. Something else starts with an R, not just rate, but rise over run, indeed. Rise over run. And I'll throw in as a bonus rate of change. We could say change in Y divided by our change in X. So is a rate of change, really commonly referred to as rise over run, but important to remember that rise is change in Y, up or down, and run is change in X, left to right, horizontal direction. We have become familiar here with the coordinate plane, wherein the up and down line represents, we call it what? The y-axis, absolutely. And then the horizontal line is the x-axis. Yes. And the entire time we have worked on these linear equations, linear functions, which represent lines or equations that have constant rates of change. So let's say, what can you think of that changes? Can you think of anything that maybe grows or changes at a constant rate? Plants? Yeah, sure. Yeah, I would be surprised if the sunflowers outside grew 1 foot, 1 foot today and 2 inches tomorrow. Absolutely. I thought of like hair. I think they say that your hair grows about 1/2 inch a month. So we look at, change in X, maybe a passage of time, or 1 month that passes. My hair grows 1/2 inch, and then another day passes. My hair grows another 1/2 inch. But what are things that wouldn't change as constantly? Something that might vary. Yeah.
Temperature.
Temperature. Ooh, yeah, absolutely. Could be, especially this time of year, it's going to be, 20 today, 30 tomorrow, 50 this weekend, 20 again. And that was a great example. Another one I thought of was like someone who might be on like a weight loss journey. They might lose, 1 pound this week, 1 pound this week, maybe they stay stable, maybe the next month or week they lose 2 pounds. But we are always looking at, with these linear equations, we're modeling data that has a constant change, a constant rate of change, and that's why we have these nice straight lines when we work with this data, rather than zigzag lines. Like getting in the car and setting the cruise control at 65 miles an hour, traveling at a constant rate. So let's see. In just a second, we'll get into one of the first forms that we use to model this data, slope-intercept form. Let's review some of the lines that we see in their relationships. When a line continually increases, left to right is continually increasing, it's going up. Is that slope positive, negative, 0, or undefined? The positives have it. This slope is positive. Oop, didn't have my pen going, but it worked out. How about in the top left here? Yeah, someone was quick on the jump. I heard negative. Something that continually slopes downward is negative. What about this flat line here? I heard it. I heard the correct answer. Any other concurrence? This is 0. Yep. And in a line that is totally vertical, totally up and down is undefined. Well done. Undefined. Down here. Okay. I'm going to jump here to slope-intercept form, and we can come back to that last slide. Slope-intercept form is written as y equals mx plus b, where m is equal to what? The slope, and b represents what? The y-intercept. Absolutely. Where m is slope, and b is the y-intercept. So, unless told otherwise, if we didn't have a y-intercept, our graph would simply start at 0. Our graph would not just our graph, but our line would simply start at 0. That's not always the case. For example, the person I referenced who might be on their weight loss journey, you know, they're going to have a starting weight and then trend downwards. Let's refer to your packet. And let's refer to problem 21. I want you to put a star next to this question because you're going to see something very similar to it on the test. Wait, once, could you please read question 21 out for me?
The function x equals 30x plus 70 describes how the temperature of an oven is T in degrees Fahrenheit changes with respect to time, x measures in minutes. What does y-intercept tell you about the temperature in the oven? What does this look like?
Wonderful, thank you so much, and well done. Okay, I baked some sugar cookies last weekend, so I had to use my oven. I had to bake the cookies at, I think it was about 350. But when I turned on my oven, did my oven start at 0 degrees?
Yes.
0 degrees would be really cold. 0 degrees is colder than the weather outside today. 0 degrees is, today outside it's about 20 degrees. And it's not 20 degrees or even 0 degrees in my house. Let's see. Go look at the thermometer on the wall for me. Please. Tell me what the number reads.
It's over here.
Yep, the
This white
thermometer.
thing.
It's the little screen. 70? Okay, yeah, 70. So that is what our function reads on this problem. Function says, let me write it just as well as Peyton said it. Temperature of x is equal to